All right, here's another problem. It's just a comparison of two motors. So we have a Y connected motor and we have a delta connected motor. Now these motors have exactly the same voltage, nameplate rated voltage. They're same 75 horsepower motor and they have a full load current of 96. So both of them are the same. So basically same everything when we're looking at the two. But we're going to look at, and here's the question, which motor of these would be physically larger of the two motors, or will they be the same physical size? And let's have a look here. So I did a little sketch here for you. So here on the left hand side we've got a delta connected motor with the three, and just for illustration purposes, we've got 3 coils delta connected and it draws 96 amps of line current. On the Y motor we have our same, or we have that the 3 coils of the Y motor are connected up in delta, and it also draws 96 amps. So what would be, comparing the size of the two, which one do you think will be a larger motor, or will they be the same size? So what we got to think about is the area occupied by the windings itself. This will create the biggest size difference between the two. So the windings will have to be large enough gauge to carry the current going through them so the motor won't overheat. So I don't want to put too much current through each one of these coils and cause that motor to overheat. So it's got to be big enough gauge to handle the current going through it. So will the windings of each motor have the same current going through them? Well, if we look at these windings, they are in the phase, okay, on either motor. All they're going to see is phase current. On the Y side, we know that the phase current is going to be the exact same value as line current. So phase current is going to be the full line current here, 96 amps. There's only one path for it to go through. So essentially we got to have large enough gauge windings that's going to carry that full line current. If we were to look at this and compare it to something that we know, such as our tables in our code book, it'd be approximately a number 3 gauge size. Over on the delta, we know that the current would come in, the line current would come in, and it would split between the two coils. So it goes to the phase current. So let's calculate the I of the phase here. So I phase would be equal to I line divided by root 3 for the delta motor. So 96 divided by root 3 comes to about 55.4. Okay. So if we use our table 2 again, just for practicality purposes, that's about a number 6 gauge if we sized it based off that. So we'd see that this Y motor would have to have number 3s, and the delta motor would have to have approximately number 6, which is much smaller. So the Y motor would end up being physically much larger than the delta motor, and probably a little more expensive to manufacture. So for that reason, when we get to the larger horsepower motors, they're almost always usually delta. At the smaller horsepower motors, they could be Y or delta.